The second half of section 4 involves sigma notation. Sigma notation is a mathematical notation that we use when we're finding sums. Sigma notation is basically called summation notation. So there's a bunch of stuff that we need to learn about sigma notation. So I'm going to point that stuff out to you, and this is up to you to just kind of get comfortable with what it's saying. It's just notation that tells you stuff. So, sigma is the Greek letter right here. That letter is called sigma. There's a little sigma also. Greek alphabet has uppercase letters and lowercase letters, just like our alphabet has. You've already worked with some, like pi. You know that one. That's a Greek letter. Theta from geometry. You use the lowercase theta in geometry. A lot of times in geometry you use other Greek letters like alpha or beta. But a lot of the Greek letters get used in mathematics. Typically they represent angles if they're lowercase. But uppercase typically represents some sort of operation. And that's what we're doing here. I, the letter I that you see there, is just called the index. Has nothing to do with imaginary numbers at all. It's called the index. And I isn't the only letter that we use there. A lot of times you'll use I, but you could use I or J or K. Most of the time it's going to be one of those three letters. Like I said, this is just shorthand notation for representing a series. It's actually really convenient once you learn it. So there's a few things about the notation we need to know. First of all, I is the index, and the first value of I is that number right there. So our term 1, if you want to think of it that way. It doesn't mean that the first term in the series is 1. It just means that it's our first number. The formula for the terms in the series is sitting right there. And notice it's written in function notation. F of I. You could have an entire function in there. Then you would plug in whatever number I is right here into that function and perform whatever operations it's telling you to do and get a number as your answer. The last value of I is that number right there. It's called n. In our series equations, we'd have a sub 1 being our first term. There's your a sub 1. And then we'd have a sub n being our last term. There's your a sub n. So what happens is you take 1, you plug it in, you figure out what that first term is going to be, and you write it down. Then you go plus. You change 1 to 2. You count up by 1. Then you plug 2 into your function here. Simplify it all down, get your second term. Then plus. Change this to a 3. And you continue to count, and you continue to plug in that number each time, simplify it down, and you add it on to the end of your series. And you continue changing up by 1 each time until finally I equals whatever this number is right here. So if that was 10, then you'd go I equals 1, plug it in, simplify it down, write down that answer, plus. Change this to 2, plug it in, simplify it down, write down the answer, plus. Change this to 3, and you continue doing that until you change this to 10, plug it in, simplify it down, write down your answer. And then you have 10 terms that you add together, just like in a series like we've been working on in this section. And once you're done with that, then you have your answer. So this is a short way of writing down a full series. This is the mathematical way to do that. Vocab word here, limit. The least and greatest value of n in the series. Your limits are here. You're starting at 1 and ending at n. The least and greatest values of n in the series. The way to find a sum is to find the first and last values in the series and use the appropriate equation for the arithmetic series. So what I'm telling you is, all you have to do is find the first and last values in the series. A sub 1 and a sub n. You also need to know how many terms there are. We'll deal with figuring out how many terms there are here in a minute. But then once you've done that, all you need to do is use S sub n equals n times a1 plus a n over 2. If you know the number of terms that this thing is telling you that you have, then you know n. And then all you have to do is figure out a sub 1 by plugging in 1 here and simplifying it down. And then find a sub n by plugging this number in here and simplifying it down. All right, first example, find the sum. And by the way, this is how you would read this. With that Greek letter sigma sitting right there, you would say the sum from k equals 9 to 21 of 5k plus 6. And you're looking at it like, what in the world does that mean? We plug in 9 first. Yep, that's going to give me my first term. So we're going to go equals. Plug in the 9. 9 times 5 is 45, plus 6 is 51. So that means my first term is 51. Now I add 1 to the 9 and I get 10. 10 times 5 is 50, plus 6. So I'm going to write plus 56 because this is a sum. We're adding all these terms together. Plus, change the 10 to 11. 11 times 5 is 55, plus 6 is 61. How far do we go? To 21. We got a long way to go. So let's do one more here. What number did we just leave off on? What's k now? K is 12. We have k is 9, k is 10, k is 11, now k is 12. 12 times 5 is 60, plus 6 is 66. Okay, so that's how you generate the series that they're telling you to generate. That's all that notation is doing. This is a much simpler way to write all of these terms out. And you can already see that's a lot of terms that we're going to have to write out. How many terms is it? No. It's not 21 terms. We stop when k is 21. But k started at 9. Maybe 12. So I don't want to write all this out, but we do have plus and then some more stuff and then plus. What's my last term? 21. So I plug 21 in for k. 5 times 21 is 105 plus 6 is, okay, 111. Now my sum formula is S sub n equals n times a1 plus a sub n over 2. Do I know everything I need to know? Almost. I almost know everything. I know a sub 1, what is it? And I know a sub n, what is it? 111. So all I have to do is this first one and this last one, and then figure out that guy, n. So to do that, you got two choices. You can count. We start at 9, so 9 is one term. And then 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. How many terms do we have? We have 13 terms, not 12. But how could I get 13 from these two numbers sitting here? You guys came up with 12. How did you come up with 12? You subtracted them. 21 minus 9, right? But we need 13 terms. Very good. This number is n. We have to subtract whatever that number is, which normally is I, but we used k this time. It's the same thing. But then we have to add 1 to it. It's kind of like if I assign you the problems number 5 through 10 all. How many problems is that? It's 6 problems. Number 5, number 6, number 7, number 8, number 9, and number 10. That's 6 problems. It seems like 5 problems, but it's not, because you're also doing number 5. So n, this number, I, this number, but we got to add 1 to it. That gives me n equals 13. Meaning the number of terms. So now I have S sub 13 equals 13 times 51 plus 111 over 2. 51 plus 111 is 162, divided by 2 is 81 times 13. What is it? 1053. So there's your sum. And it comes from this problem right here. Now, notice, did I need to do all of these terms here? No. But I wanted to do all these terms so that you could see how the summation notation works. If you only have a few terms to do, it might be easier to just write out those 3 or 4 terms and then just add them together without having to use this formula right here. But if I give you something that has like 181 terms, there's no way you're going to do that. You're going to want to use this shortcut, and then this. Okay, we're going to go the other way now. To write a series in sigma notation, first find the explicit formula for the sequence. Figure out what is generating, what equation is generating that series or that sequence. Then once you've done that, find the limits, so your first term and your last term, and write the summation in sigma notation. So we have multiple choice problem here. What is the summation notation for the series? And the series is 7 plus 11 plus 15 plus all those missing terms in between, plus 203 plus 207. So what have they given you here? They have given you a sub 1 and a sub n. What else did they give you? The common difference. So let's write those down. First of all, a sub 1 is 7. A sub n is 207. And the common difference is we're adding 4 each time. Now, my little helpful hint here says first, find the explicit formula. Well, we can do that now because we have all the information that we need to write the explicit formula. Because it's a common difference, it's what kind of a sequence or what kind of a series? It's an arithmetic sequence, yeah. So I can use the equation a sub n equals a sub 1 plus d times n minus 1. Now substitute everything in. So we have what? A sub n equals times n minus 1. But what is a sub n? 207. So we can use this now to find out the number of terms, which we have to know. Because a sub 207 means the 207th term. The 207th term is not 207. 207 is the last term, which is a sub n. Okay? This will allow me to find out what term number 207 actually is. Now when I solve for n, I'll get n equals like 15 or whatever it is. And that tells me that the 15th term, or whatever the number is actually 207. Okay? So that's why I had to write a sub n here. All right, so let's solve now for n. What do we do? Subtract 7. Don't distribute. Subtract 7 from both sides, and now we have 4 times n minus 1 equals 200. Now divide everything by 4, and we have n minus 1 equals 50. Now we add 1 to both sides, and we get n equals 51. So actually, the 51st term in this series is 207. That's a good observation. Notice that we have 51 terms involved here. Now take a look at these limits that we have. Here we're starting at 1 and going to 51. Here we're starting at 1 and going to 50. Here we're starting at 1 and going to 50. Here we're starting at 1 and going to 51. How many terms are there in 1 to 51, and how many terms are there in 1 to 50? Remember what we did on the last problem? We did n minus I, and then we added 1 to it. So if I go 51 minus 1, I get 50, but then I add 1 to it, and I get 51. So there'd be 51 terms in this guy, which means that there's 51 terms in this guy, which means that how many terms are there here? 50. And how many here? 50. But I need 51 terms. So can I eliminate a couple answer choices here? Yep, this one and this one are gone. So I'm down to just A or D. Here's how you do the rest of this problem. It says, find the explicit formula for the sequence. We almost did right here. We're going to take that and simplify it down. A sub n equals 7 plus 4 times n minus 1. I'm going to leave it just like that and distribute. A sub n equals 7 plus 4n minus 4. And then we're going to combine like terms. A sub n equals 4n plus 3. This right here is what generates the next term in the series. Do you see that anywhere? Yeah, it's A. This generates the next term in the series, just like this generates the next term of the series. This little equation sitting here is the same as this equation sitting right here. It's just over and over and over again. So that summation notation that you see here, the sigma, is basically just telling you this repeated from this number to this number. It's exactly the same thing. My answer is A. To convert sigma notation to our arithmetic series equation, decide how many terms n there are. And we talked about how to decide how many terms there are. N minus I plus 1. Compute the first and last term. Then use the equations, or equation, this guy. That's the preferred one. If you really want to torture yourself, you can use the other one, but this one works just as well. And then note, the series must be arithmetic for this equation to work. We have not learned how to take care of a geometric series yet. That's the next section. You have to have an arithmetic series for this stuff to work. If it's not an arithmetic series, it doesn't work. You will need to evaluate the sum the long way. So I can give you a summation like this, but it's not actually arithmetic. You'll have to do it the long way. How would I know, just by looking at this or at this, if it's actually an arithmetic sequence? Basically, if you were to graph it, this would form a what? A line. This would form a what? A line. Yeah. But if I put a square on that, that would form a parabola. If I put a square root on this, that would form a sideways parabola. Not linear. So take a look at the equation that you're given. If you could graph it and it would form a line, then you're dealing with an arithmetic series. Okay? If not, then you have to do it the long way, which is write out all the terms like they've done here, and then add all the terms together. It's kind of a bummer, but that's how you'd have to do it. If it's not arithmetic, then you have to write them all out and then add them all together. So hopefully there's not very many. That's not a big deal if it's only like 3 or 4 terms. That one was arithmetic, so we didn't have to do that. Okay, so let's take a look at this first one. The sum of 5n plus 3 from n equals 1 to 70, or the sum from n equals 1 to 70 of 5n plus 3. What do we need to do here? Okay, it's in summation notation. We have sigma notation here. Should we? The first thing we should do is look at it to see if it's an arithmetic series or not. This one is, because if I was to try to graph 5n plus 3, I would have a line. All right, so we're good. We can use our methods. We have the summation and we have our sum formula. So what do we do now? What? Plug 1 in. Okay. And that would be what? Oh, I thought you were saying a sub 1. A sub 1 is my first term, which is 8. I plug 1 in. 5 times 1 is 5, plus 3 is 8. What else do I need to know? A sub n equals, we take 70 and plug it in. So I have 5 times 70 plus 3, which is, yeah, because 5 times 70 is 350, plus 3 is 353. What else do I need to know? I don't need to know the common difference. But if I wanted to, I could ask you what the common difference is. Just by looking at this right here, what is the common difference? With a linear situation, the common difference is the same as the slope. So the common difference would be 5. If you don't believe me, try the second term. Take 2, plug it in. 5 times 2 is 10, plus 3 is 15. How much do we change from 8 to 13? 5. Common difference is 5. No, we need to know n, the number of terms. How many terms are there here? There are 70 terms. Yes, but other people were saying the wrong thing. There are 70 terms. How do I know it's 70 terms? N minus I plus 1. 70 minus 1 plus 1 is 70. So n equals 70. Now I know everything I need to find the sum. Don't have to find any other terms. Those two, the first one and the last one, and then the total number of terms. So now I'm going to write S sub what? 70 equals 70 times over 2. So that's S sub 70 equals what? The sum of the first 70 terms in that series is what? I just want the answer. It winds up being 35 times 800, 361. What do you get? $12,635. So if you were to sit there and write out all 70 of those terms and then add them all together, you'd wind up with 12,635 as your answer. How about the second one? We have to do it the long way, yeah, because this is not linear. How do you know it's not linear? Because we're squaring a variable, which makes it not linear, which makes it not an arithmetic sequence. So we have to do this the long way, which means we have to generate each term. But luckily, how many terms are there here? There's only 7 terms. So that's not that big a deal. Plug in 1, what do you get? 0. 1 minus 1 is 0, squared is 0. Plus, plug in what? Plug in 2. We plugged in 1 already. Plug in 2. 2 minus 1 is 1. Squared is 1. Plus, plug in 3. Minus 1 is, squared is 4. Plus, 4 minus 1 is squared is plus. Yeah, so what's the next one going to be? 16. And what's the next one going to be? 20. So it would be 1, 2, 3, 4, 5. We're plugging 6 in. Minus 1 is 5. Squared is 25. And we're plugging in 7, right? How hard is it to take out your calculator and just add those together? It's not hard. It's probably a fast way to do it even. What do we get? 91. So the long way isn't that bad, as long as there's not that many terms. So, what do we do on that first one? Get your a sub 1 and your a sub n, okay. S sub 40? Okay, so a sub 1 is negative 5, good. And a sub n is, plug in 40 and you get 112. And we need to know the number of terms. We find the number of terms by taking the top number minus the bottom one, and then adding 1. So 40 minus 1 plus 1 is, so n equals 40. Now, S sub 40 equals negative 5 plus 112 over 2. So what do we get for an answer? 2140? Okay. Good. And the next one, what are we going to do there? Got to do it the long way, so we got to generate each one of these terms. How many terms are there? 4, so that's not going to be that big a deal. What do we get for our first term? 1 plus 8 plus 27 plus 64. And when you add all those together, you get 100? Wonderful. How about this last one? It's gross. Is it negative 1? Think so? This one's kind of tricky. We'll talk about that in a minute. What? There are 101 terms, that's right. And each time we're plugging in this number as an exponent. So the easy way to do this problem is to think about what is happening each time. If we plug 0 in, we have negative 1 to the 0 power, which is what? Negative 1 to the 0 power. Anything to the 0 power is 1. That's my first term. Plus, now I'm plugging in 1 here. I have negative 1 to the first power, which is negative 1. Plus, now I have negative 1 to the second power, which is positive 1. Then negative 1 to the third power, which is negative 1. Okay, so these add to 0. This was an even number and the next odd number. This was an even number and then the next odd exponent, right? So we're going to wind up with 0 after we have done the 99th term. Or sorry, after we have done the 100th term. Which is going to leave us with a positive 1 when we do our last term. So 1 is the answer. Right, because we have 100. We're going to 100. Our last term is going to be negative 1 to the 100th power, which is going to be even. We've gotten to 0 until that very last term, so that makes it positive 1. That's how you do this using algebra. Your calculator, of course, also does this. And it makes it really, really easy to find the sum using summation notation, using sigma notation. On your calculator, you have this template button right there. Bring up the template button and you will see a little sigma hanging out there with a bunch of boxes around it. That is your sum template using sigma notation. So you'll click on that one and there it is. There's your Greek letter sigma, and you can define everything the same way that you see it in the problem. So for this first one that we have sitting right here, we use the letter n. That's fine. Use the letter n. Move over to n equals 1, and then press up to get to your upper bound. It was 40. And then press over to get into the parentheses to define the function. And the function was 3n, so I'm just typing in 3n minus 8. Press enter, and you get 2,140. That's very nice. Let's do the second one, because this is going to get kind of confusing if you're working with exponents. So we want to bring up the sigma notation again, and this time we're going from n, and you can use I and j and k and x or whatever letter you want there. N equals 1 this time, and our upper limit this time is 4. And now in the parentheses we need to type in the n to the third power. We don't want to go outside the parentheses and try to put an exponent in there. So we're going to type n exponent button to the third power within the parentheses. Now press enter and you get your 100. This makes you really happy? What if you forget? You can use the calculator. But what if I give you something messed up? You won't be able to use the calculator. It is possible to do that. So you have to know both. That last one was, let's do it. We have sigma notation again. And what was the letter at the bottom? N again, okay. Equals, oops. This one was 0 though, wasn't it? So we'll start at 0, and then we'll go up to 100. And then the function was -1 to the n. I don't want to go outside the parentheses. I have to stay within these parentheses. So I'm going to type in parentheses, even though I'm in parentheses, -1. Then I can close the parentheses and raise that to the nth power. I have to type it that way because this function is defined within those parentheses so that this thing will actually work. So you need to use parentheses before you can do the problem. Press enter and you get 1. So you're welcome to use the calculators on your summations that involve sigma notation. The ones that don't, though, you'll still have to use S sub n, that formula. And that does it for section 4.